All right, thank you. So I want to go over the environmental specifications of the MDK, but more generally, I want to talk about environmental testing for modules as well as touch on the certification, both for the regulatory certification and what we see as what would be needed for entry into the module marketplace. Where's my clicker? So the goals of the environmental specs are twofold. One, it is to protect the end users, then the modules, and the platform in that order of priority. Secondly, because we are intending this phone for the entire world, we want to make sure that the modules will be able to operate through a range of environments and geographies. So we were part of Motorola, and so we had access to lots of mobile standards and specifications in this area. And so what we are doing currently is trying to figure out how to adapt those best practices to the ARA platform. So we can't just use them outright because we're very different, right? Unlike a traditional smartphone, where essentially you have a one-off device and you can do a bunch of testing on it, we have potentially an infinite number of potential configurations, right? And secondly, we're not just one manufacturer. In fact, we have all of you. So we are currently doing some functional testing on the prototype, and we will adapt those standards and then push out what we learn into the MDK in the future. So when necessary, our strategy is to aim to provide just survivable limits for each of these areas, and then leave the details of the qualifications up to you guys, because inherently you guys will have your own qualification procedures for your companies. But in the case that if you don't, we will also provide reference implementations, which are essentially test procedures that demonstrate compliance. So let's get started with thermal loads. So thermal loads are very, very important on the ARA platform. So heat generated from components in a module either travels up through the module shell into the end user, which is bad, or it goes down through the PCB into the Endo and spreads to other modules. So in the prototype, we control thermal loads by essentially setting limits on the average power that a module can get. In fact, there's a 2 amp current draw limit for any module. We envision, however, that in the objective platform, that we would have a much more sophisticated active thermal management system. So we've begun some preliminary analysis on trying to understand how heat dissipates on the phone. We have looked into trying to put together an active thermal management system with a thermal controller, with a bunch of thermal sensors, both in the Endo as well as potentially in the modules. We've looked at other ideas like a heat transfer system whereby we essentially move the heat source or heat from a major heat source away from that module into other areas of the phone. We're also thinking of potentially involving the user, right? So if you have a phone configuration where two very active and very hot modules are placed right next to each other, we could send a notification to the user and tell them, this is not an advisable configuration, please swap your modules. And then lastly, we have looked into the fact that you can potentially use diversity from inherent in your set of modules to reconfigure the phone on the fly. So as an example, if you had an LTE module and a Wi-Fi module, and if one of them were to get really warm, you could turn it off and then essentially just use the other one. So the next slide is electromagnetic interference, EMI. So ultimately, here we want to ensure that modules don't interfere with one another. Right? And we have several approaches to this challenge. The first is that the MDK specification requires all modules to have a safety shield to cover essentially all the electrically active components on the PCB. Now, this serves two purposes. One, it prevents users from accidentally touching the sensitive components on the PCB, but it also provides a very convenient Faraday cage. So we've actually specified that the safety shield should be made of, I think, nickel or some other functionally equivalent metal. So when we talk about EMI, we are concerned about radiative coupling, and to an extent, regulatory requirements provide us a convenient baseline on which to use for our own requirements. But we really have to look beyond these radiative coupling limits because we have modules that are operating essentially very, very close together, centimeters apart, right? As you've heard, we also have this contactless, high-speed contactless data interface that uses both capacitive and inductive coupling. And then to top it all off, we have electropermanent magnets. So as you can imagine, this is Maxwell's soup in this very, very concentrated and tiny region. So what we've done is we've been working to model and understand the EM environment within our phone. We're also in parallel looking at ways to develop both non-emitters and emitter modules. So Derek Linden, in fact, from X5, will give a presentation tomorrow on how we intend to do RF modules. Of course, all this, once we've learned more, we will flow down what we've learned into requirements and push that out in future MDK releases. Next up is SAR, specific absorption rate. So this applies to emitter modules. This is the level of RF energy that an end user can receive. And it's strictly set by regulatory bodies around the world. I am here to say that the ARA platform provides no additional requirements beyond those that are required by current regulation. Next up are environmental specifications that relate to effects on the modules. So starting with ambient temperature and humidity. So the MDK currently provides this table and lists them, has them as operational limits for the prototype modules. That is strictly not correct. These numbers actually correspond to the maximum range for an accelerated aging test using this thermal cycling profile you see here. They are not meant to be operational limits. So we've received a lot of comments, in fact, on this in the forums. This is exactly the type of feedback we want to get from you guys. We flagged it, and I personally will be looking into it and providing further clarification in future MDK releases. Next up is electrostatic discharge, ESD. Here we have pretty wide consensus on an industry standard. And so we use the IEC standard as well. It specifies the discharge rates as well as the processes and the configuration for how one does ESD tests. So the exact discharge locations are currently TBD, but you can guess that they'll be around areas between part lines, right? So between the module base and the module shell, and in other sensitive areas like the interface blocks. Next is vibration. So vibration ensures that we have structural integrity for components within a module and between the various subassemblies. These are some very typical test specifications for that. You essentially put your module or your device on a shaker table, shake it in each axis for 5 minutes using those parameters. Finally, we have shock or the drop test. So I'm going to say first and foremost that we are concerned as well about modules breaking apart or the phone breaking apart and the modules flying out of the phone when a user drops it. So we're working currently to understand what that looks like in a real functional prototype. And so whatever we learn, we're going to feed back into our design of the EPM and on specifications for the drop test. So industry standard for drop test is between 3 and 5 foot. So we've chosen 4 foot as a starting point. There are, of course, various ways in which one can perform this test. Orientation of how you orient the modules. We will probably have to do a test where the module is by itself and when the module is in a phone. And then, as you can see here, this is a human-enabled test, but perhaps there'll be an opportunity to do some kind of robotic assist on these tests. Next up, I want to share some initial thoughts that we have on how regulatory certification might work for our modules. So we envision that you, the developers, the module developers, will be responsible for certification of your modules with some assistance from Google. So when you have a module ready for regulatory approval, you will apply to the regulators yourselves. And for example, you would get an FCID for your device. Then Google will supply you with with one of two things. Right? We can give you a high fidelity computational model of the phone, and you will use your corresponding high fidelity computational model of your module. And then using that, you can perform computational analysis to figure out what the worst case conditions are in terms of EMI and SAR. Similarly, in a more traditional method, we'll give you an Endo, a test Endo with some test modules that, again, simulate worst case RF conditions. And then you plug in your module, figure out what are the interactions between these other test modules, and see what the worst cases are. You can use, for example, a near field rapid scanner to help you do that quickly. Once you figure out what the worst cases are, then you take the results to an accredited lab where they'll probably want to do more tests. And then submit the results for approval from the regulators. And finally, so the details of the module marketplace are still being worked out. But as a condition to entering the marketplace, we think there will be some minimal certification required. And so this chart includes a laundry list of all the types of data that we think you might need to provide to Google. So starting on the left side, these are items that pertain to the fact that you will have a business relationship with Google. So you'll need a digital signature to verify that you are who you are. You'll have a reputation score on the marketplace, which is informed by consumers. You'll have some sort of customer support back-end interface so that consumers can know who to call when they have a problem with your module. Second column is tech data package. So these are electronic files that you will submit. So drawings, manufacturing, and QA processes. If you have specific userland drivers, shell geometry and antenna geometry. So not every module will have this, of course, but if you do have a custom module shell, you'll have to submit drawings for that. And then lastly, performance specs and compositional rules. So compositional rules are if your module has, can only fit at the top of the phone, things like that. We also envisioned that you would send actual engineering samples to Google as well, and then we would take those engineering samples and run a bunch of tests on it to verify quality and spec compliance. So the first thing we would do is probably just to verify that your module meets geometric constraints that we've set. For example, your module actually fits into an Endo. We'll verify that the EPMs have the sufficient hole strength. We'll do a voltage and current sweep, and then do a bunch of tests to exercise the network stack and the Android and software stacks. And then lastly, we'll probably do some version of all the environmental tests that I previously went over. And lastly, the last column is a set of artifacts if you intend to use the metamorphosis models and tool suite. And these are some of the artifacts that they require. So if you do that, then we will have essentially a formalized model that is equivalent to your engineering samples. And this could help speed up a lot of the certification efforts. So I think that is it for me.
All right.
Questions?
Elwin, thanks so much. That's great. All right, we've got a question from IRC. This is from RAM. They show drop/shock test for a phone. What if there is a bad module design which cannot withstand the drop shock of the phone? Are there guidelines on drop test on those particular modules?
So as I said, we're still trying to work through how a shock test would work in our platform. And so once we do perform a test on the functional prototype, and we'll be able to answer that question much better.
Okay. And then Jürgen's fan club is looking for him. Will Jürgen be there tomorrow? Will Jürgen be there tomorrow?
Jürgen will be here tomorrow.
So Jürgen, you are in demand. Let's see what other questions we got.
Easy question. Come on.
Oh, I got a question from Twitter user Ermenko_Paul. Did you mean to say the contacts are coated with nickel or nickel-plated steel?
Sorry, they are nickel-plated steel.
Okay.
Yes.
That was a totally random question from the internet.
Nickel will probably not be good.
Yeah.
Right?
Yeah. Okay. That was great. Okay. Those are all the questions we got, but we got a couple of folks in the room. Go ahead.
Hello. Let's make an assumption that somebody's trying to submit a module that is like, for example, super sensitive sensor, which doesn't meet, for example, vibration requirements.
Okay.
But like it doesn't meet it because it cannot, like due to its purpose, like it has some details or something like this. So would you approve this one, or you'll reject it because it doesn't meet the requirement?
Yeah, I think we're working out the exact nature of how that certification will work for the marketplace. But I would hope that we would make conditions available for special cases.
So then I have the next question, which comes out of this. So these will be like individually, or like you'll test each module individually. It wouldn't be like automatic. So like some are getting
Yeah, we totally envision all the, at least for the Google certification part, to be completely automatic. That we get the samples in, we'll place it on some sort of rig, and all the tests will be completed automatically. Especially when we get up to hundreds and thousands of modules, it's going to be impossible to do this manually.
Okay, thanks.
All right, let's go over here.
Yeah, just one point of clarification. I mean, normally when they build a phone, the phone is certified, for example, by the FCC as a complete unit.
Right.
Now, are you saying that every module, whether it's an emitter or not, I mean, obviously there will be some level of emission from any digital
Right.
circuitry or what have you, but you're saying that every module has to be independently certified, say, by the FCC?
So let's be clear, right? So currently, there are various ways in which the FCC provides equipment authorizations, and so non-emitter modules currently are just digital devices, right? And you don't need to go to an accredited lab to get it certified. You can do that through a verification process, right? And the same would apply to our modules that aren't emitters, right?
Okay, so it would depend on what class of
Right.
module
Right,
that
but
it was.
but the device is at the module level, right? So that's the distinction, I think,
Okay.
that you were trying to get at.
Okay,
Perhaps.
thanks.
You have a question over here?
Yes, will users be able to plug in modules that don't go through the certification process? Say they buy something from SparkFun as a development kit or something. Will they still work, or is there going to be an interlock that prevents non-approved modules from going in?
That's a great question. I think as a whole, we want to. I mean, there's this spirit of making, right, and that's throughout this project. That goes throughout the vein of this project, and so I think that would be something that we would want to support, right? So that people at home who want to make a module for their own use, right? And that, by the way, is a specific exemption from the FCC. If you make 5 or less and you don't sell it, you don't have to care about the FCC at all. So in those cases, yeah, absolutely, I think we want to support that kind of effort.
What's the difference between Android, where you can load your own apps, or an iPhone, where you have to go through the Apple Store? So I'm hoping, this will be the same.
All right.
Yeah.
Paul, any color to add to that answer? No, you're good. All right, cool.
I'm Joseph.
Hey.
Do you have any future plan for FDA certification as a medical device, something like that?
Yeah, actually, originally we were planning to release some initial what do you call it, guidance on FDA certification, but we pulled back because we're still trying to figure out what it is we should say in those areas. So stay tuned.
Cool. A couple other questions popped up on IRC. So PF420 says, the certification process sounds expensive. Are there plans to offer discounts or additional assistance to startups or academic customers?
Well, which certification effort?
I don't know, the process.
Okay, so the regulatory certification is no different for the ARA platform as with any other device, right? So they don't incur any additional costs there. For the module marketplace, those details are to be worked out, but I think at least for the computational models that those would be relatively inexpensive. I think we would make those relatively inexpensive. So.
Okay. And then the other question that popped up from Smadger on IRC is, okay, so how will refunds work through the marketplace for faulty modules?
That is beyond my expertise. Sorry.
Okay. It may be too early to even address that, I think, as Paul indicated earlier. What really ATAP is focusing on is developing
all modules will just work. They will never fail.
That's right. There'll never be anything that